Right, this is a question from A21, Physics for January 2010. And this is question 1. A wire of cross-sectional area A and length L is clamped at one end and is stretched by a force F applied at the other. This force causes an extension X. Write down expressions for the stress sigma acting on the wire. So, sigma, of course, this is very similar to the previous year's question, or 2 years before that. Stress is equal to force over area, and sigma, or epsilon, which is strain, is extension divided by length. And always use the symbols that they have asked you about in the question. If they use an E here, you use an E here. Don't just be making up your own. And that's worth 2 marks. So that's very easy, 2 marks there. Part B, a copper wire of length 2.7 metres and diameter 1.5 millimetres is clamped at one end as shown in the experimental arrangement in figure 1.1. It is stretched by the application of a load of 468 newtons. Now it doesn't matter that the load's pointing down this way, it is causing a load of, or tension in the wire, of 468 newtons. So that is of course the force on the wire. Given that the Young modulus of copper is 128 gigapascals, and they are expecting you to know how to change that into meters or into pascals. Calculate the extension of the copper wire when the load is applied. So we're going to write down, first of all, we know that Young's modulus is force over area divided by extension over length, and we're looking for extension. So that is force times, remember this is, if when you divide by a fraction, the same as multiplying by it upside down, so it becomes FL over X times A. And we're looking for X, therefore X is equal to FL over E times A. And then also we also know that area is pi diameter over 2 squared, which is pi times 1.5 by 10 to the minus 3 over 2, and that's squared. And so to do a calculation, X is equal to, the force is 468. The length of the wire is 2.7 metres. Young modulus is 128 and giga is by 10 to the 9. And then the area is that pi times 1.5 by 10 to the minus 3 over 2. So it's pi times 0.75 by 10 to the minus 3 squared. And whenever you do that, you get 5.6 by 10 to the minus 3, or 5.6 millimetres, and your answer's in millimetres. So be careful about things like that, where they give you a different unit and you have to convert your answer. Calculate the strain energy per unit volume stored in the wire when it is extended. So the first thing you have to do is calculate the volume of the wire. So the volume of the wire is its area times its length. So its area is pi r squared times its length, and that's equal to pi times 0.75 by 10 to the minus 3. No, sorry, per unit volume. Unit just means for a length of 1 metre. So, no, actually it doesn't. I was right there the first time. So you're multiplying by the length of the wire, which is 2.7. And the volume of the wire is 4.77 by 10 to the minus 6 metres cubed. So E is equal to half Fx, which is equal to half times 468. And then that's multiplied by X, which is our extension from part 1. And the extension from part 1 is 5.6 millimetres. That's by 10 to the minus 3 metres. And so when you multiply that out, you get 1.3104 joules. So energy per unit volume is 1.3104 divided by 4.77 by 10 to the minus 6. And that gives you that gives you an answer of 27471. I'm going to round the 6 up to a 7. And that's joules per metre cubed. but we have to write our answer in kilojoules. So that's, you're going to convert this to 274. We'll round it up to 275 to three significant figures. 275 kilojoules per metre cubed.